So hello everyone, welcome to this video lecture series for data science and machine learning using Python. We have already covered the basic of Python and now it's time to explore some of the specific library used in data science and machine learning. In this series, we'll focus on NumPy, a powerful library for numerical computing in Python. So are you ready to dive in and learn how to use NumPy to perform complex calculations and manipulate data with ease? So without wasting much of your time, let us quickly get started. First of all, let us have some introduction about NumPy. So NumPy was created by Travis and he is the person who is actually the founder of Anaconda. So you can see and you can analyze the vision of this person who is already a creator of Anaconda, and he must have realized the importance of certain functions, certain complex mathematical calculations that needs to be done within flash of the moment or within few seconds. So for that he has created this particular library and that we call as NumPy. Now let us quickly go and see the comparison. So whenever we see a comparison, we'll compare between two major things. One is the already used mathematical expressions or mathematical concepts that we are using in Python. Another one is by using the NumPy. So let us quickly go and compare them. First one is the Python math. You can see whenever we want to do the multiplication or whenever we want to make power of something, for example, you can see here 7 into 3 is 21 and 7 to the power 3 is 343. This is one of the things that we are performing using maths. Second thing is we have two lists, list 1 and list 2. We are adding this two list and we can see the addition of this particular list. So this is normal math that we use in terms of Python. Now whenever we go for NumPy maths, we can use the same thing using the NumPy maths. For example, here you can see pure Python version. This is particular function which is giving you the pure Python version. So we are using it using pure Python version, and the second one is NumPy version, wherein we are using NP. We are importing NumPy as NP and we are using NP, and then we are adding this to list. Now let us see what difference does NumPy library makes. So you can see by using this particular function, we can see the tremendous difference in the times and the loops that NumPy is using and the pure Python version is using. And if you compare both of them, it is 33 times faster than a normal math function or any normal Python version. And that is why NumPy becomes very important and it is irreplaceable when it comes to linear algebra or when it comes to complex mathematical problems. So now as you already understood how powerful this NumPy library is, we should also look the reason behind it, why NumPy is having this tremendous power and why NumPy is being used this widely. So again the same question, what are the reasons that makes NumPy superior in comparison to normal math functions? So there are two major reasons for this. One is the memory allocation that it does, and second one is speed that it is having. What are the reasons behind them? Let us look one by one. So first is the memory. So NumPy array have the same data types, while on the other hand, if we see arrays or if we see list, it can contain multiple data types. It can have integers, it can have float, it can have different things. Even list can contain list can contain tuples. But NumPy arrays are homogeneous, meaning they store elements of the same data type, which makes it very memory efficient and it takes less space to store the data. And this is one of the reasons that NumPy is widely used and also one of the reasons for doing the mathematical calculations much faster. Another reason for its fast speed is its power to use something which is called broadcasting. That means if you see the example here, if we have any normal array, for example 1 2 3, and we just want to add 5 into this particular array or this particular list, so what it will do, it will add 5 to each of them. Even if this second element is just for one block, it creates 2 additional block and then adds to this. Otherwise, in a normal sense, it should have given the result as 5 1 2. But what NumPy does is it adds 5 to this place and this place, all the 3 places, and this is what we call it broadcasting. and numpy does it exceptionally well when it comes to broadcasting, even for the one-dimensional broadcasting, even for the two-dimensional broadcasting, even for the different shapes of the broadcasting. Numpy does a very fascinating job in terms of broadcasting, and this is one of the most powerful things that numpy contains. Okay, now enough of theories, let us go and have some hands-on, because most of you must have came here to have something hands-on with Jupyter, and we want to use the numpy library and we want to explore what are the dimensions of numpy library. So let us quickly get started with that. So here we are in the Jupyter notebook, and most of you must have already installed numpy in your system if you have already seen my videos in the machine learning environment creation. So you must have already installed numpy in your system, but if you haven't installed the numpy, don't worry, I'm here to help you out. All you need to write here is just pip install numpy. Remember to use this symbol before this. So now I'm assuming that all of you must have installed the numpy in your system. The next thing that we need to do, for those who have already installed the numpy in their system, it will look something like this: requirement already satisfied. And after that you need to import numpy as np. Np is something which we consider as standardized form for numpy whenever we are using numpy. But if you want to import numpy as a, b, c, d, e, f, g, h, there is no problem at all. You can import numpy as whatever li's name that you want. So it is something which we have as a standard format. That is why we generally import numpy as np. After that, the first thing that we are going to learn is the ndarray. Don't get threatened by its difficult name. It's nothing but n dimensional array. So that is why it's called ndarray in shortcut. Now what is this n dimensional array and how do we implement it? It's very simple. Write any variable is equal to np.array and 1 2 3. So this particular a will get this dimensions 1 2 3 and it will be a n dimensional array. So that means that there is no limitations of dimension. It can have n dimensions. It is still an array, or that's something that we call as list. This is for one dimension. Supposing if we are having more than one dimension, then we can implement it like this. The first dimension is this, the second dimension is this, and the double this brackets, 2 layer of brackets. So if you want to have 3 dimensions, 3 layer of brackets, 4 dimensions, 4 layer of brackets. After this we have minimum dimension. So if I would have something like this, if I say the minimum dimension should be 2, I don't want any dimension less than 2, then we can use this particular method wherein inside this np.array we just define ndim. That means dimensions or the minimum dimension should be 2. So here we can see we have defined 1 2 3 4 5, and the moment we get output it will be of 2 dimension. Now if I say it shouldn't be 2, it should be 3, I just want 3 dimensions, so it will give you 3 dimensions. If I say no, I want 4 dimensions as minimum, it will give you 4 dimensions as minimum, but we don't require that at present, so we'll just have 2 dimensions minimum dimension that we require. Now one thing that you must be wondering, why I'm writing import numpy as np again and again. You don't need to write that again and again. It's just that I've written it so that every this particular code can act as individual code. So if someone wants to use this particular code, they just need to use this chunk of code and it will run. Otherwise some people will see this particular thing and may not run for them because they haven't imported numpy as np. So anyways, you don't need to write this numpy as np again and again. Now the third thing is dtype parameter. Dtype is what? Dtype is nothing but a data type. So what type of data that you want? You want to create an array of 1 2 3, that is good, but what type of data that you want? So if I say no, I want this data to be a complex type of data, so it will create a complex data for you. So you can see my array was 1 2 3, but the data type was complex, so it has given it in the complex form: 1 plus 0.j, 2 plus 0.j, 3 plus 0.j. If I want to have different data types, so it will give different data types. Now one more question that must be striking in your mind, that is, sir, please tell us what kinds of data types that we have. I mean, you have just written complex, but you don't know is this is complex even data type in numpy or not. So don't worry, the data types in numpy are Boolean, integer, int c, int p, int 8, int 16, int 34. So this all are integer types having different sizes. And this is the first one is Boolean. You must have you must know what is a Boolean, and I've already covered this in previous videos of introduction to Python. You can go and watch that video to have better understanding of this data types. Again, unsigned integers that we have, floats we have, complex we have. So this all are the data types that we have inside numpy. And after this particular data types that we are dealing with, something more that we must know is how file name can be used to access content of each column. That means suppose we have one file name that is dt, and we have created it in terms of age. So we want to create it as in terms of age, and we have given it some data type that is int 8, and now we have our complete array 10 20 and 30. We have given the data types as dt. That means we have created our own kind of data, and that is we have defined that this data type must be age, and the moment we print age, it will give you age. You can see 10, 20 and 30, it is considering it as age. So this is how we can create some new data type that you want to have. The next is numpy array attributes. So for example, if we have any particular array of numpy and we want to know its shape, so what exactly is the shape of that particular array, or we want to reshape that particular array, so how will we do that particular thing? So first, you can see we have just defined this array, and this two-dimensional array you can see here. Now if I just write a.shape, so it will give you an output. Its shape is 2 cross 3. Its shape is 2 cross 3. Okay, now if I just want to reshape it, so again there's the same array that we have, and I will say a.shape is equal to 3 by 2. So it's originally is 2 cross 3, and I just want to change it to 3 cross 2. That is something also we can do. It will change this 2 cross 3 to 3 cross 2. Those who are not able to understand what are you talking, sir, 2 cross 3, 3 cross 2, please go and check some of the basics of the matrices, because anyway you have to read about the matrices. You have to have an understanding of matrices, its inverse of the matrix, and the determinant and other aspects of the matrix, because that is the base of any data science or machine learning that you're going to do in future. Anyways, I'll try to create a different video lecture series for complete math that we are using for data science and machine learning. But just for the understanding purpose of this, you may just go and check the basics of the matrices so that you understand the numpy a bit better. So the next thing that we have is numpy array creation. So the next one is numpy array creation routines. Now if you want to create any numpy array, we can create it in different terms. So we can just fill all the array that we are having with zeros. We just want to have it empty or something of that kind. The first thing is numpy.empty. Though it is saying numpy.empty, but whenever we are using it, it just gives some random outputs. It just feels random output with that particular format that we're having. Suppose we are having 3 into 2 matrix, so it will create a numpy, and it will just fill them with any random number. So supposing if I just run it again, it will again give another number. Again, if I'll run it, it will again give another number. So it will keep on giving another numbers to this, and this is how this numpy.empty will take place. Now one of the important thing that you must understand why it is called numpy.empty, because even if you want to fill it with any other thing, you can fill it. So consider it kind of acts as empty only, though, because it needs to give certain data to this. That is why it is giving, and it's showing you certain data on the first place. Otherwise, if you want to use it for any other, you can just take it as empty data for your numpy array. That is why it's called numpy array. And second one is numpy.zeros. So most of you must have been thinking, so if you want to have a numpy.empty data set, we can just fill every data set with 0. Why we are not doing that? So again, the reason is because we have still another set of function that is numpy.zero that fills the data with zeros. So for example, in this particular example, you can see it is filling the 2 by 2 matrix with zeros, and we can just define data type as per your choice. This means that if you are already having some existing data, for example, we are having some strings, we are having some list or something of that kind, which are not in the form of numpy, how can we convert them in the form of numpy? So let us quickly look at them. So first of all, importing numpy as np, then we have a list named as x that is containing 1, 2 and 3. Now how we convert them? A is equal to np.asarray x. That means whatever list or whatever thing that we are having, we are converting them as array, and the moment we see its output, output will be array of 1, 2, 3. So first of all, it was list of 1, 2, 3, and now it became the array of 1, 2, 3. So if you want to see what x is, you can also see what x is. So x is 1, 2, 3, but a is array of 1, 2, 3. So I hope you understood the difference that it is creating. The initial phase was a list. The second thing, it became a numpy array of 1, 2 and 3. After that, if you are having some iterations, for example, if you are having a list which is ranging from 0 to 4, that means its range is 5, so it's ranging from 0, 1, 2, 3 and 4. And if we just want to see its result, it will be 0, 1, 2, 3, 4. Why it is having a dot after it? Because we are using data type as float. Again, the same thing, np.frombuffer, so from iterations. So here it was np.asarray, here it is np.fromIterations. Very simple concepts. Next thing is numpy array from numerical ranges. So whenever we are having any numerical ranges, how we can form that particular numerical ranges. So we can see np.arange. What is that range? From 10 to 20. The difference should be 2. That means 10, and then we have 12, and then we have 14, then we have 16, then we have 18. It will not go to 20 because 20 is excluded. So if we see the output, it is 10, 12, 14, 16 and 18. It will not go till 20 because it's less than 20. So So this is the range that we want to produce, right? So if I just want to include 20, I'll just write 21 here, and will also include 20. Okay, so this is what range mean. And then we have something which is called as indexing and slicing. We have already seen this indexing and slicing in our previous video of Python for data science and machine learning, but I'll just give again a brief. And believe me or not, NumPy has almost same indexing and slicing that we have for normal Python. So you can see we have an array that contains 1 2 3 4 and 5, and if you want to see what element is in its second index, so it will give an output as 3 because it's 0th index, first index, and the second index, that is 3. Okay, so there's indexing, and then we go for the slicing. So we have this complete array from 1 to 10, and if you want to slice it from 2 to 7, that will give 3 4, that because this is second position, so 0 1 2, so second position till 7th position. Okay, so this is how the same way and same concept of slicing that we generally use in Python. So nothing, no difference at all. Okay, if you want to see the output, you can see the output here. Now here comes the advanced indexing. That means there are certain things that we have in advance inside the NumPy, though we can also use this advanced index in some parts of Python also, but it is very interesting thing that you all must know inside the NumPy, because this is widely used at certain times. For example, if we're having an array that contains this all dimensions, and then if we want to have an index, so we'll just create two index. One will say this is the row index and this is the column index, so this represents the row, this represents the column. Now we are creating a mask or a flag, we can call it as selected. Inside that we have row indexes and we have column indexes. Now if I'll say that print that particular thing, so it will print the particular things of that particular row index that we are having or that we said, and it will also print the column index that we said. So this is advanced indexing that we call as. So this is a bit of explanation that I've already given you. After that we have Boolean indexing. So for example, if you are having this particular array and then we want to have something, we have a condition that we want to select the elements which are greater than 5. I want all the elements which are greater than 5. I don't want someone who is less than 5. So what I'll do, I'll create a variable named as selected, and I'll just use this particular condition as a mask, and then I'll try to print this. This is again a form of advanced indexing. So it will just print all those who are greater than that particular amount that we have decided. After this we have iteration of the NumPy array. So how generally iterations of NumPy array is done, it's again very simple. For element in array, so this particular array, print element, as simple as we generally iterate using any other list or any other stuff in Python. Again the same kind of iterations with some multiplication logic that we are using here. So we are creating the power of 2 to all the elements that we are having. Same thing, nothing difference. Like it is I'm just focusing less on this particular part because they are this part of NumPy is same as what we've already discussed inside the Python. Now something which NumPy is known for, its linear algebra. So the first thing that we are going to discuss in the linear algebra in which NumPy is used, the dot product. So supposingly if you are having an array 1 and if you are having an array 2, so if we just want to create a dot product of the two particular matrices, it will give an instant result just by using np dot function. Now what exactly a dot product? Again I'll still say please go and have some basics of matrices just to understand this NumPy for this particular point of time. But if you want to have it in a longer term, I'll again create a mathematical playlist for this, and you could enjoy and you could learn more about the mathematics related to data science and machine learning. For the moment being, I'll just explain you what is happening inside this. So what does this dot product is doing is 1 multiplied by 4 plus 2 multiplied by 5 plus 3 multiplied by 6, which is overall 32. So this is the dot products that NumPy is creating. The first is the dot product that we generally use whenever it comes to the matrices, because there are many functions in which we have to use the dot products, and without dot products you cannot build any useful things in data science or machine learning. After this we have matrix multiplication. Again you must have read about the matrix multiplication. So if you want to have if you have two matrices and if you want to multiply two matrices, we use matmul. This particular function we use, and it multiplies two matrices and gives the output. It is also possible to use this particular symbol @ symbol to calculate the matrix multiplication. How we use this particular symbol? This is first array, we just consider this a matrix. This is first matrix into matrix 2, and it will give the same result. You can see it is giving the same result. So there are two methods by which we can multiply the matrices. After this we have a determinant of matrix. Determinant is for the time being just considered as cross multiplication of matrix, but it's a big concept that you should try and cover from your end. Again, as I said, I'll also create some playlist for mathematics so that you can understand what exactly is this determinants and other stuff. But this determinant is also very useful. Now, if you have some matrices and some form of linear algebra and that we want to solve that particular linear algebra, so for the solution of that linear algebra, we again have one function in the numpy, that is linear algebra, that is LIN, this for linear, and ALG is for algebra dot solve. We have an A matrix and we have an B matrix, and it will give you the solution for that particular matrix. It seems very easy, but believe me, the moment someone will give you a copy and pen and will tell you to solve this particular linear systems of AX is equal to B, or for that matter any matrix multiplication of the complex form, or for that matter any matrix inversion and all, you will have a lot of problem doing that with pen and paper. And in that particular case, numpy is really essential and useful. So I hope this all function that I have given you in the numpy will be useful for you the moment you go with the implementations of this particular machine learning models. When you want to, suppose if you want to just import certain libraries and you are using it, in that particular case you will not use them, and believe me, that will not be helpful for you in becoming some good data scientist or becoming a good machine learning engineer. If you want to become a good data scientist, or if you want to become a good machine learning engineer, one thing that you have to do, and that is you have to understand the base of that particular mechanism. Whatever machine learning model that you're doing or whatever data that you are playing with, you have to know the base of stats and base of maths behind that. And for implementing that base, you have to use numpy library in its pure form. So this is all hands-on that we had with numpy. Now quickly go and I'll give you one question to solve, and I hope you'll enjoy solving that particular question, because that is something which is taken from real life scenario. So let us quickly go and see that. So we are done with the hands-on with Jupyter. Now we'll go with the question. The question for you is that a company has collected data on number of sales made by each of its sales representative over past year. So there are different sales representative of a company, and I have some data related to those sales representative. The data is stored in 2D numpy array. This is something that you have to do. You have to store that particular data in 2D numpy array. The name of that array is sales, where each row represents a sales representative and each column represents a month. The row will represent sales representative and the column will represent a month. The company wants to calculate the total sales for each representative over the past year. So we have certain months, we have certain sales representative. All we want to calculate is the total sales. This can be done using something which is Excel or something of that kind, but I want you to use numpy. This is a very base question for numpy. Though it might seem on the first occurrence, it might seem a bit difficult and tricky, but believe me, it's just the summation of two arrays, and I hope you will be able to do this question. But anyways, you don't have to worry if you are not able to do this question. You can find the link below for website, and you can go to that particular website and you can find the answer for this particular question that I'm sending. But please do this from your end before looking at its answer.